right, so here we are with 12.6. So far in the last couple sections here, we've learned about translations, then we learned about reflections. Now we're going to learn about rotations and rotational symmetry. All right, so rotation, so some vocab here. So rotation is turning an object around a point. Okay, and generally speaking, that point is going to be our origin on a graph, or 0, 0, but it doesn't have to be. So it could specify a different point, although I don't necessarily think that it will do that very often today. All right, so let's go ahead. So center of rotation is the point, is that point that I was talking about. So that the point that the object spins around. Spins, oops, my eye didn't really go there, spins around. That's the center of rotation. Okay, the angle of rotation is the measure in degrees that the object was spun. And this is either going to be clockwise, whoops, clockwise, or, and I'm going to go above it because I ran out of room. So it's either clockwise or, actually I can go below it, counterclockwise. Right? So we don't talk about rotations in terms of left and right or up and down. We talk about clockwise and counterclockwise. So I want everyone, if you don't know what that means, look at the clock right now. Okay, do you see how the second hand is moving around the clock? The way the second hand is moving is called clockwise. Okay, if you went the opposite direction of the second hand, that would be counterclockwise. All right, so hopefully that makes sense. Rotational symmetry then, so we talked about line of symmetry yesterday with the reflections. Rotational symmetry is if an object could be spun around its center center with a C, there we go, and line up with itself. Right? And this again is measured in degrees. In degrees. Okay? And that's why you might see my protractor hanging out way up top there, because we're going to need that today to decide what some angle measurements are. So we will use that here in a minute. All right? Objects that normally have rotational symmetry, if you think about a perfect star, right? You can spin that a certain number of degrees and it would line up with itself. The fan, right? Once it spins around so far, it would line up where it started. Or it would line up in a position that matches how it started, right? It has to be less than 360 degrees. Because if it's 360 degrees, you just end up right back where you started, just as if you didn't turn it at all. Okay? So example 1. Tell whether the transformation is a rotation about the origin. So it's saying, are we spinning it around this point, right? Around 0, 0. If so, give the angle and direction of the rotation. Right? So if we look at A, right, it's clearly being rotated. However, if I were to rotate this about the origin, right, then so what I want you to do is I want you to connect this point of it with the origin. And then the matching point would be this point right here. Connect that with the origin. Okay, from there to there, it looks like about 90. And it's always going to be multiples of 90 when it's asking you to do this. So if we look there, it looks 90. Okay, so now I'm going to switch colors and we're going to do the same thing for a different point. So let's do the tip. If I draw the tip from here to here, whoops, it didn't change colors. I really need a different color. If I draw the tip from there to there, and then I draw the tip from there to there, well, that looks like 92, right? So maybe it is. Okay, let's try one more. So I'm going to go lime green here. So let's go with this point. So if I go from here to here, then I go from here to here, that's 90. So we're looking like it totally works. So the answer to this one would be yes. The measure, right, the angle, well, it's 90 degrees. And the direction, so is it clockwise or counterclockwise? In this case, it's clockwise. And this is exactly how I want you to answer these questions, right? Yes or no, and then if it's yes, it's a degree measure, and then clockwise or counterclockwise, right in a row. Yes, 90 degrees clockwise, or no, or yes, 180 degrees counterclockwise, right? That's how I want you answering these questions. All right, let's look to the next one here. So if I look at the next one, from here, that will line up with this one. Well, that's a straight line. And I believe we learned earlier this chapter that a straight line is 180. So let's see if I get a straight line every time. So let's try this one. Boom, to boom. Oh yeah. Let's try another one. Boom, to boom. Yeah. So it is. So yes. In this case, it's 180 degrees. Now, if it's 180 degrees, think about it. Think about it. Does it really matter if it's clockwise or counterclockwise? Right? If you're not sure, stand up. Okay, spin 180 degrees clockwise. Okay, go back to where you started. Spin 180 degrees counterclockwise. Okay, did you end up in the same spot? Well, hopefully you did. Otherwise, you didn't do it right. So yes, it's 180 degrees, and you can say whichever one you like best. Clockwise, counterclockwise, it doesn't matter. Both of them would be correct. All right. Now, let's look at C. So if I draw a line from this point to this point, that has to match up, right? Look at how your shape is situated. That has to match up with this one. Okay, well that looks like 180. Let's try a different one. Okay, this would have to go here. This would have to go there. That's not a straight line, right? There's definitely a little bend here. So since they're not the same, this is not a rotation. Okay, they have to be the same. If they're not the same, it's not a rotation. All right, so now we have some coordinate rules, right? Just like we had coordinate rules for translations, and then we had coordinate rules for reflections. Now we have some coordinate rules for rotations. So if we're rotating at 90 degrees clockwise, we're going to switch the coordinates. And what do I mean by switch? Well, do you see here how A is 2, 3, and A prime is 3, negative 2, right? So we literally flip-flop the X and the Y. And then you multiply the Y coordinate by negative 1. So XY goes to Y, negative X, right? That's really important. This is a 90-degree clockwise, okay? So make sure you know that. 90-degree counterclockwise, so counterclockwise. Okay, again, we're going to flip-flop, right? So A here, A prime here. See how these two things switch spots? So XY, and then we multiply the X coordinate by negative 1. So XY goes to negative Y, comma, X. Right? And that's super important, so make sure you circle or star that. Okay, so those are our two big rules when we're rotating. So let's try an example here. So example 2. Draw a triangle ABC with those vertices. Okay, well that's pretty simple, right? So A is 1, 1. B is 3, 4. Hopefully I don't mess this up like I did last time. C is 4, 0. Right, connect those dots. Oh, I already messed up. I said B prime, and it's just B. All right, connect those dots. Boom. Then, find the coordinates of the vertices of the image after a 90-degree clockwise rotation and draw the image. So I drew the original. Now, it's 90 degrees clockwise. So I look back at my notes and I say, what's the formula for that? Well, 90-degree clockwise, that's this one. So it goes, xy goes to y, negative x. xy goes to y, negative x. So I gotta flip them, I gotta flip-flop, and then change the sign of the second one. So if I flip-flop, that becomes 1, 1, but then I have to change that sign, so this would be negative 1. Okay? B prime, flip-flop, so 4, 3. Change the sign, so negative 1, negative 3. Okay, C prime, flip-flop, so 0, 4. Change the sign of the second one, so negative 4. And that's how I do it. That's how I teach it in geometry. That's how I still do it. So flip it first, then worry about changing the sign. Okay? So, now I'm graphing the new ones. I'm going to graph the new ones in red. So A prime is at 1, negative 1. So this is A prime. B prime is at 4, negative 3. C prime is at 0, negative 4. And hopefully we ended up with a triangle that looks the same. Right? It's turned. And if you don't believe me that's the same, go ahead and take out a piece of scrap paper and you can trace the original and then hold your finger on the origin and turn your paper and it should line up with your image after you turn it 90 degrees. Okay? If you have any questions, make sure you're asking Ms. B, or you can ask Mrs. Schmidt during resource, or I will be back on Tuesday. Okay. So, go ahead, try the checkpoint. Is it just this one checkpoint? Yep. Go ahead, try the checkpoint here. When you're done, go ahead and let's do what we did before. Let's just do our A prime, B prime, C prime in the answer box to your right. And then you can check your graph when you hit continue in the video. So first I'm going to draw the original. So A is 1, negative 1. B is 3, negative 1. Whoops, that's B. C is 4, negative 4. Come on. Okay, connect the dots. Oh man, I did the prime thing again on A. I just get so excited. I like primes. Okay, so there's that. So then I'm doing 90 degrees counterclockwise. So my rule is that xy goes to, and even I have to go back and check, negative yx, negative yx. And again, you'll be given that on your test, so that's not something you need to memorize. You just need to know how to use it. Okay, so I'm going to flip them, right, flip. So A would go to negative 1, 1. But then I got to change the sign of the first one, so this becomes positive 1. Okay, flipping B, I get negative 1, 3. But again, change the first, so that's positive. C would go, if I flip, it would be negative 4, 4. But then change the first sign, so that's positive. So now graphing my primes, or my image, A prime would be at 1, 1. B prime is going to be at 1, 3. C prime is going to be at 4, 4. Okay? And again, your triangle should look the same. It's just been turned. And again, if you want to double check by tracing on a scrap paper and spinning it around the origin, feel free. Okay? All right. We do have one more rule here for our rotations. To rotate a point 180 degrees about the origin, you multiply each coordinate by negative 1. So the image is the same, whether you rotate the figure clockwise or counterclockwise, right? And that's what I kind of hit on earlier when we had one that was 180. It doesn't matter which direction you go. So all you're going to do is multiply both things by a -1. So it becomes negative x, negative y. Okay? So this is your rule for 180 degrees. So make sure you have that marked in your notes so it pops out because you're going to need that as well. So let's try one. That's 180. It says draw a triangle MNP with those vertices. Okay, so M is at -4. -4. There we go. N is at -3. -1. N. And P is at -1. -2. That's P. Next dots. There we go. Okay. It's 180 degrees. So our original xy goes to -x, -y. Okay, so I'm going to just multiply. I'm just switching the signs, essentially. Multiplying by -1 is just switching the signs. So -4 would go to +4, +4. -3, -1 would go to +3, +1. -1, -2 would go to +1, +2. Right, so then it's just a matter of drawing my new points. So M prime is at 4, 4. N prime is at 3, 1. And P prime is at 1, 2. Connect my dots, boom, boom, boom. And again, it should look the same, it's just rotate 180 degrees. And you can check that if you want using scrap paper and then holding it at origin. All right, that does finish as far as like rotating things about the origin. If you have questions on that part of it, you should definitely be asking Ms. B or Mrs. Schmidt sometime today, because otherwise I will not be back until Tuesday. All right, last concept for today then is identifying rotational symmetry. So can I spin an object less than a full circle for it to line back up with where it started? Okay, well, let's look at A here. Is there anywhere that I could line this up or spin it around, right? Spin it around the center. Is there any way I could spin it so that it would line back up with itself? Well, no, because there's only one arrow, right? So it doesn't have rotational symmetry. So it doesn't have rotational symmetry. Just doesn't. 360 degrees would end back where I started, but that's not rotational symmetry. It has to be less than 360 degrees. Okay, if I look at this one, if I spun it so that this lined up there, and that one line up there, that one line up there, and that one line up there, right? I could do that 4 separate times. So it does have rotational symmetry. So then the question becomes, how do I figure out what the degree is? Well, do you see how I could do that 4 times before I got back to where I started? Well, the full circle would be 360. And since I could spin that 4 times, right, like a cogwheel 4 times, I'm going to divide by 4, which would give me 90 degrees, okay? So it has 90-degree rotational symmetry. I'm not really sure why it leaves you such a big blank, but that's all I expect you to write. The figure has 90-degree rotational symmetry, right? And you could think of it spinning the other way too. In geometry class, generally we talk about counterclockwise rotations, and so that's why I'm drawing my arrows the way I am. All right, let's look at C. Well, C has a circle in the middle, so that's helpful, right? Right, that's your center of rotation, okay? All those spikes appear to be the same, so I could rotate it so this lines up there, that lines up there, then it would line up there, and then 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 there, right? So how many cogwheels could I turn this? Well, I could turn it 1, 2, 3, 4, 5, 6, 7, 8. I could turn it 8 times. So I'm going to do 360 divided by 8, which would give me 45 degrees. Okay, so the figure has 45 degrees rotational symmetry. And again, that's all I expect you to write. I'm not sure why I leave such a big spot, but that's really all you have to write as far as rotational symmetry goes. Oh, it says direction of rotation. Okay, it does say direction, but here's the thing. You could rotate it either way. You could. So you don't need to put the direction. Okay, that just seems silly because it's up to the person doing it, which way you would rotate it. All right, so that does conclude it for 12.6. Again, if you have questions, please ask Miss B or Mrs. Schmidt or track me down on Tuesday when I'm back. But yeah, that's a long time to wait. So please get those questions answered sooner rather than waiting for Tuesday if at all possible. That does wrap it up. I will see you guys on Tuesday. Have a great weekend.